Hello chemists, and today we're going to talk about our lab on solution stoichiometry, acid-base standardization. So our objective of this lab is to determine the concentration of an unknown solution of hydrochloric acid. And we're going to do that by titrating it with a known concentration of sodium hydroxide. The sodium hydroxide solution will have been determined its concentration by titrating it against a standard called KHP. So a little bit about standardization. In titrations, we always add slowly one substance that we call the titrant to a beaker full of a known volume of a substance that we usually call the analyte. Now, as we titrate it slowly, drop by drop, eventually we get to the neutralization point where all of the titrant has reacted with all of the analyte. And this is usually indicated by a color change that we initiate with an indicator that will change colors. In this particular lab, it's going to go from a clear colorless to what we'd like to see is a whisper of pink. You want it to say pink. You don't want it to scream pink, although that's going to happen, guaranteed. Now, standardization deals with whether we have a primary or a secondary standard. Now, a primary standard means it is something that is super stable, that we know its values. And usually that means our primary standard is going to be a solid. In that case, that's the KHP. So the sodium hydroxide is titrated against a solid that we dissolve up called KHP, and we get its concentration based on that. That KHP is called our primary standard. The sodium hydroxide in this case is going to be used to determine the concentration of the HCl. Since it wasn't directly known, that's going to call it a secondary standard. It had to be standardized first against something else. A little confusing, but that's the difference between a primary versus a secondary standard. So we're going to do a number of titrations. Again, we always do multiple trials in the laboratory. And this is going to be very important for getting that pink, because the first time that students do the titration, they often go well past the equivalence point, that net neutralization, and it starts to screen pink. It'll be bright fuchsia. We're going to do it again, hopefully this time a little slower now that we know where we want to slow down at that equivalence point to try to get closer to that whisper of pink. So we're going to do this titration at least 3 times, depending on how much time you have in the lab. Now, the calculations are discussed in the lab manual. There is a really nice stoichiometric setup done for this lab with some sample data. Please make sure that you're following that sample data when you're using your values so that you can get your best calculation results.
So we've got a couple of experiments where we specifically need to be worried about our glove protocols. And those experiments are the solution concentration, the titration standardization, and the titration for the vinegar concentration. So when we talk about those experiments, it's absolutely necessary that we wear gloves for the entire experiments. For the other experiments, gloves are recommended. They're not necessarily necessary. It's never that we don't want you to wear them, but you don't have to wear them for the other experiments. For these, it's necessary. So I want to show you how to properly put on a pair of gloves, how to take them off, and then talk about what are proper protocols for using those gloves in those experiments. So let's talk about how we put those gloves on. So we're going to take gloves out of this container. Here's 1, here's 2. I'm going to set those down. We're going to make sure that we put them on appropriately. So we want to make sure that we get our thumbs into the thumb spots on our gloves. So that's 1. I want to get that over my watch because I want to make sure I don't kill my watch while I'm wearing it. And then I have my second one, if I can get this thing sorted out because they're all shoved in there, not necessarily easy to put on. Some people take their rings off before they do this. It depends on how big your rings are. I have ones that are tiny so I don't break through my gloves. That was a decision we made. But these are how I put them on. Putting them on is the easy part. Okay? Taking them off is not the easy part. When I'm in the lab and I'm working with these gloves, everything is fine. If I have to leave the lab for whatever reason, I need to go to the bathroom, I need to take a phone call, I need to eat something, I need to do something outside of the lab, including taking a drink, then I need to take these gloves off. So if I'm going to take these gloves off, I can take the first one off fairly easily, right? Fairly simple. But when I go to take the second one off, I want to hook my fingers inside of it, grab a hold of the inside, and then pull it off like that so that I'm holding the inside when I'm dealing with it, not the contaminated outside part of the glove. And then I take those off. I'm then going to wash my hands to make sure that I get anything off of my hands that shouldn't be there, because sometimes we accidentally get chemicals inside, okay? And then I'm gonna go do whatever I need to do. When I come back to the lab, I'm gonna go to the front bench. I'm gonna wash my hands again, just because I'm paranoid. And then I'm gonna put on another pair of gloves. And I'll do that before I handle anything in the normal part of the lab. Okay, because chemicals can be just about anywhere. So we wanna make sure that we're dealing with clean hands before we put them back into those gloves. Now, things that we need to make sure that we're dealing with when we talk about these experiments. We put those gloves on before we handle anything, because you may not be the first lab for that week. So the things that we're dealing with may not be as clean as we want them to be. So we want to make sure that we're dealing with, everything in gloves. So make sure we've got those dealt with the gloves on. Anything that we deal with in the lab needs to be done that way. Anytime anybody is working with anything, doesn't matter if it's chemical or not, for those labs, we need to be wearing those gloves, okay? So I think that's everything I need to talk about with the gloves. So thanks, guys. I appreciate it.
Hi, guys. For this lab, we're going to talk about the first titration, which is the standardization of sodium hydroxide with KHP. For this lab, there's a couple of things that you're going to need, of course, very, very specifically, very, very important. You're going to need gloves, and you're going to need goggles, of course, and then make sure that you have your closed-toe shoes and long pants on. You're going to need your phenolphthalein indicator, sodium hydroxide and hydrochloric acid. Please, 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 please double check which one are you grabbing. They look exactly the same. If you grab the wrong one, this is not going to work. Then you're going to need some sort of funnel with a very, very thin stem. Then you're gonna need this right here. This is called your magnetic stirrer. So this is gonna stir for you, so you don't have to do it manually. Then you're gonna need this little tiny white pill. This is a magnetic stir bar. So if you see, it's magnetized to it. You're gonna need your burette stand, a waste container. Then you are going to need a Lermar flask. You're either gonna need a 125 or a 250. It doesn't matter which one you grab. Either of them work well. And then you're gonna need a graduate cylinder. Mine's already pre-filled with water, but you don't have to pre-fill it with water yet, so I'm just showing you. And then you're gonna need your KHP, which is your potassium hydrogen phthalate. Then you're gonna need weigh boat, scapula, and then of course, your electronic scale. So let's go ahead and get ready. And I want to start by refreshing you on how to weight. You haven't really weighted powders that much. Make sure that we're not eyeballing it. And then put our gloves on, put our goggles on. If you are allergic to latex, highly recommend you bring your own gloves. Now for this lab, before I begin, a couple of safety reminders. If you get any acid or base on your hands, please take off your gloves immediately and wash your hands for about 10 to 15 minutes. If they're so itchy afterwards, please let your instructor know. So if you get it on, let them know, and if it's still itchy afterwards, please let them know as well. So to begin, we are going to weigh our solid. You're gonna use a weigh boat, and then when you put your weigh boat on the scale, make sure that you tare it. So there's a little T, some of them have a 0 in it, so I'm gonna press the little T, and that should give me a 0.00 grams. Make sure that every time you use it, you are tearing it, because there are multiple people using it, and not all weigh boats weigh the same. So don't assume that because you teared it and I used it, it's gonna give us the same, it won't. Then we're going to make sure that you wash your scapula and dry it well before you use it. This is a scapula, just to double check. You can also use a spatula, which is the thinner ones if you would like. And then when you are done with this, make sure you cap it. So you're gonna need either 0.5 grams or 1 gram, depending on which version of the lab you are doing. And you don't need exactly that, but you wanna get as close as you can. So I don't wanna eyeball it, you shouldn't be just dumping it in. So what you're gonna do is you're gonna do slowly, just grab, and then you're gonna pour slowly until you get what you want. So I got 0.26, and let's add 1.5. Then I just want a little bit, and you would do a little bit at a time. The idea is not to waste any. So we're gonna go ahead and get our, I'm gonna use 0.5, you may be using a little bit more. And then if you get any extra, what you are going to do is you are going to, oh, look at that. Perfect. Oh, I'm gonna get a little bit more, so that's okay. So as long as you recorded, it's fine. Now, if I get like 0.6 and I want a 0.5, then I'm going to find a waste container and I'm gonna put it in the waste container. So let's say I don't want the 0.02, then I will use my waste container and just pour it into my waste container. We never pour back into your solid container because it will contaminate it. So once you have your solid, we're gonna go to our station for a titration. And then we wanna get our trial one ready. So of course you're gonna flip up your burette. So remember, you're gonna grab it from here, and then you're gonna open it, flip it, and then close it. Make sure that it is well adjusted. Sometimes they're tilted, and if they're tilted, they're really, really hard to read. And then right now, this is open, so you wanna close it. You wanna go all the way like this. So when you're looking at it, if this is a stopcock, if the stopcock is parallel to your burette is open, if it's perpendicular to it, it's closed. This is not closed. It has to be all the way like this, so all the way. And then I already pre-measured my 50 milliliters of water. We're gonna put this in here. To do so, you're going to take your weigh board and you're gonna flip it like this, and it goes in there. If you need to get any extra solid out, you're gonna use some of your pre-measured water. It helps if you have a little pipette and just put a little bit of it. Don't get any extra. It has to be some of your pre-measured water. And then it will go in there. And then we need our little magnetic turbine. Put it in there. And then the rest of the water goes in. And then to dissolve this, you are going to put it on top of the magnetic stir, and then you're going to turn on your magnetic stir like so. Now, a couple of things. If this is splashing everywhere, notice how this is splashing everywhere, this is not good. You don't want to do this because you're going to lose some solution. Some of them is not going to react. The ideal speed, so this is also really, really slow. So your ideal speed is about this much. So it's still fast enough that it is dissolving, but it is not too fast that it's splashing everywhere. We don't want that to splash everywhere. Ideally, that's not what you want. So once you are ready to titrate and your burette is full, we are going to start titrating. And then once my stuff is dissolved, you are going to use some of your phenolphthalein indicator, and it's going to go in here. So you can do a pre-dissolve or post-dissolve, 2 to 3 drops. If you put 4, it's okay. If you put 2, it's okay. Just make sure you 2 to 3 drops is the ideal. You don't want too much. You don't want too little. So 2 to 3 is our ideal. This is the phenolphthalein indicator. And if you did this correctly, that's not going to change color yet. That's going to change color once we start titrating. And when you want to start titrating, so you used the burette before, you want to make sure that your sodium hydroxide is in here, and you're going to titrate slowly, 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 because otherwise this is going to change color really fast, and you're going to end up with the incorrect color. So there's 3 colors that you're going to see. You're going to see your pre-endpoint color, which looks like this, and then you're going to start seeing a change pink by pink a little bit. You're going to start seeing a couple pink drops. And then once you hit your endpoint, which is when you neutralize, when you stop, it should look like a very faint pink, like this. Tiny bit darker is okay, but if you went to this color, you went too far, right? So it should look more like this, or somewhere a little bit darker. Sometimes it tends to be a little bit darker and tends to light up, but this is too dark, right? So we don't want that. We want something this color. This means that you finish and then you stop right here. That is your endpoint. Once you are done with everything, everything is going to go in your waste container. And then please ask your instructor for a magnetic stir bar rescuer so they can teach you how to use it, and then they'll show you the first time, and then you can get it out. Please make sure that you don't throw that out in the sink. You can also put it in the waste as best as you can, and then separate it, and then use the rescuer to get it out, and then that is it. Make sure that you wash your hands at all points in time. Make sure that when you're done with the burette, you rinse it with lots and lots and lots of water. If you're having issues with your burette, rinse it with soap, then distill water very, very well multiple times, and then you can go ahead and use it.
So we're going to be talking about data collection and potential errors, and we're going to be talking about this in general. It's going to apply to all of our labs, so this is going to be the same conversation you're going to hear for every lab, but I need you to pay attention to the same things and learn to apply them for each of the experiments. When we talk about data collection, there are certain pieces of data that you're going to be asked to collect. Depending on which lab it is, that's going to determine which pieces of data you're going to be asked to collect. It's not going to be the same every time. Sometimes we're going to ask you to collect one piece of data one time, and that's because we're interested in making one observation about that piece of data. Okay, so it's just one piece of information that we're going to collect that one time. That's typically a qualitative observation that we're looking to make, so just information without a lot of specifics about it. Okay. On the other hand, we may want to take that piece of data twice to see if it's reproducible. Okay, so typically if we're going to do that, it's going to be a numeric piece of data, and we're going to be very specific about how we take that piece of information. Now, we either take it once, twice, or many times. Now that many times is going to depend on exactly what we're doing and how we're doing it. In this class, we will limit that to 3. It never goes beyond the 3. But out in the real world, that many times could be 5, 10, 20, 50. Could be any of those things. The reason for that is because it becomes statistically significant. So if you've taken Math 120 and you know about statistics, you understand that we need multiple data points to be able to determine if those data points are statistically significant. So we need to know if that's really true for the data points that we've taken. We can't get rid of them if they look wonky, if we don't know what wonky actually looks like. So we need to take multiple points to be able to see if that data is real or not. Okay. We typically don't do that in this class until we get into the later labs. So the titration labs, the first times that we start looking at that number of data points. We do start taking more data points as we go forward. So in the beginning, we take 1 data point. Later on, we take 2 data points. At the very end, we start taking 3. If you have the privilege of taking CHEM111, then you get to take many data points the whole time. So look forward to that. Okay. Those are important things for us to be paying attention to. The other thing that you need to be thinking about is what kind of data are you taking? Because the kind of data that you're taking determines how precise you need to be with the information that you're collecting. The instrument that you're using typically gives you an indication of what kind of precision you need for that particular measurement. When we talk about the electronic balance, there's only a certain number of numbers on that balance that we can look at. There's no way we can estimate beyond those numbers. So that's what we're going to record. But when we talk about something that's a volumetric piece of equipment, we can usually estimate beyond the last thing that we can look at. So on a graduated cylinder, we can estimate beyond the last measurement that's there, in between those last measurements that are there, and so we can estimate that last data point. When we talk about something like a volumetric pipette, which is one of these guys, for this, there's a finite measurement that's here, and we can't estimate beyond that. We know exactly what that is, and so if this is a 1 milliliter pipette, we know that this is 1.00 milliliters. That's the precision that we know for that particular instrument. So the type of instrument that we're dealing with will tell us what kind of precision we have for that number. It's important that you pay attention to that and record exactly what it is. You will see that when we're in ALEX, it will be very specific about that. So if you don't have the right number of numbers, that's going to be a problem. We need to know how many numbers it is, because that determines our number of significant digits, which then determines how significant those calculations are going to be, which then determines how significant our answers are going to be. So this becomes something that we have to carry through all of the calculations that we do. That's important. Okay. So that's all of the data that we collect, how we have to be careful with the numbers that we're collecting, and the type of information that we're looking at. Now, every piece of data that I collect has to have a unit. If I see numbers that don't have units, most of us will flip out about that. Okay? Units have to be there. Is it a gram? Is it a milliliter? Is it a kilogram? Those are important. We have many times that scientific numbers are recorded in the US and then sent to the UK, and assumptions are made about what units those were, and then an assumption is made when they go to the UK, they do something with it, they make some kind of conversion about it because an assumption was made, and then they do some conversion to it before they send it back to the US, and then the US gets those numbers back, still without units, they do some other conversion to it, and then some $2 billion mistake happens. Welcome to the Hubble telescope. Okay? These things happen, and this is a really big deal. If you've made it one of those, been part of one of those calculations where a $2 billion mistake has happened, that's the kind of thing that gets you fired. So a simple putting the unit at the top of the column of numbers is a really big deal. So recording your units at the top of a column or with that number becomes very important. It's a habit you should be building now. So the numbers that you're recording should have those units. Okay? So make sure you're doing that with your lab materials. Make sure that you're doing that on your tests. If they're not on your tests, that's a problem too. Okay? So those are the data that we're collecting, the number of significant figures that we have to have, the type of data that we're collecting, i.e. the units that they are. And then we need to talk about potential errors. Everything that I measure has a potential error that can go with it. So if I'm using one of these volumetric pipettes and I'm not particularly skilled at doing so, there are errors in the way that I may be doing that. It may be too high, it may be too low. There are inherent errors in that particular measurement. If I'm particularly precise in how I do it, then I don't have to worry about those errors. But if I'm not precise, I need to be honest about that. Okay? That's something that I need to record when I'm doing my data collection. So if I say to myself, okay, I wasn't paying that much attention, it might have slipped down below where it should have been, I need to write that down because that's a potential error. That can affect a lot of the things that happen after that. Because if my volume was too small, then the concentration that I'm going to end up with is going to be too high because my mass is going to be in a smaller volume, which means a larger concentration, which therefore is going to affect all of the information that I'm collecting off of that concentration. These are implications that I have to be able to think about. Okay? So anything that you do may have implications down the road. So you have to think about what you did. If you took a mass on the balance, we always talk about it doesn't need to be exact. It absolutely does not. You do not need to spend a ton of time getting the exact number that we've asked you to get. Don't. It's a waste of time. But you need to record exactly what it was. Okay? And if you do what some students do, and you don't bring your paperwork with you and write down that number when you're at the balance, and you walk away and then record the wrong number, then that's a problem, because you don't know if it's too high or too low. So one of the things that you need to be aware of is that when you go to that balance, you should be taking your paperwork with you to record that number at the balance. One of the things that I do to my students is if I see them walking to the balance without that piece of paperwork, is I will follow them from the balance back to their bench, and I will sing things like 8675309 so that they forget whatever the number is. Or if I see them writing it on a small piece of paper, then I will take that paper and burn it, because that's who I am. These are things that you really should not be doing. They're bad habits that you cannot afford. Okay? Violations like that in terms of, federal regulations are $10,000 per incident per day violations. That's expensive. Okay? Your company doesn't want that. And if you're responsible for it, that's something you can get fired for. So those are important things to think about. All of these errors have places where they can cause problems. We want you to think about the errors that you may have. When we ask you about errors, an answer that is completely unacceptable is human error. What the heck does that mean? What errors did you make? What could you have done? I may have made mistakes in measuring. Okay, what measurements could I have made mistakes with? Was I imprecisely reading my volumes because I was too lazy to pick up my things so that I was reading the meniscus correctly? If that's the case, then maybe we should talk about making sure that we're having that meniscus at eye level so that we're seeing it appropriately. Okay, are there things that we could do differently? Now, just because you're not aware of that at the beginning doesn't mean you can't improve on it as you go forward. That's part of the reason that we look at this after we do an experiment, because we're learning to look at how we did that experiment critically to see how we could do it better the next time. We need to be able to do that for ourselves and for the next person who does this lab, so that we can say, hey, try this instead, do this differently, so that maybe you can do it better next time. That's an important part of our ability to be scientists, is to be critical about what we did. It doesn't mean you're wrong, it doesn't mean you do it badly, it just means that you have to be honest about what was done. Okay? So be willing to look at what you did and what are real places that you could have made a mistake. Okay? Those are important things. When we transfer solids, often we lose some of that material, so make sure that you've noted it places where that may have happened, especially if you actually see it during the experiment. You should write that down. You should talk about the fact that that happened. So any of those errors should be noted in your paperwork, and it should be something that you talk about in the paperwork for your experiment. Okay? So those are the potential errors that you may see. Now, those are all going to be based on the particular experiment that you're doing. I'm not going to specify for each lab where those things may be, because it's your job to figure out where they might exist. Okay? This is a gentle reminder that you need to be looking at every experiment to see what kinds of things was I recording, what kind of mistakes could I have made, what things do I need to be paying attention to. So that's my spiel about data collection, units, errors that you might have made, and how those errors could implicate the data that you're looking at. So hopefully that will help you with some of those things and get you on the right track. Thanks, guys.